Hello, scholars. Today we start session 1 of lesson 29. We're going to explore partitioning shapes into halves, thirds, and fourths. So our learning target is to partition circles and rectangles into 2, 3, and 4 equal shares. We're going to use some words when we talk like halves, thirds, half of, a third of. We might use the words halves, 3/3, 4/4. And we need to recognize that equal shares of identical wholes do not have to have the same shape. So we're in for an interesting lesson. Our start slide today shows 4 shapes. Which shapes show halves? Can you look at each shape and decide if it shows halves? If someone is with you, please share what you think. I'm really interested to hear what people think about this one. Today's question is, how do you divide shapes into 2, 3, and 4 equal parts? So I want you to know use what you know about equal parts to learn more about dividing shapes into 2, 3, and 4 equal parts. So right now, think about some shapes. You might draw some on a piece of paper. Can you divide the shapes into 2? Or you can divide the shapes into 3. Or maybe you could divide the shapes into 4 equal parts. Pause this if you need to. I'm going to go on to our page for today. Number 1, shade 1/4 of this square. The whole square is blank fourths. You will find this page in the classroom. On the same page, number 2 says shade 1/4 of this square. The whole square is blank fourths. I want you to think about how you know you shaded 1/4 of the square. I have shaded 1/4 of the square because, can you maybe think about that? I'm going to go back to our problems. How do you know that this shape shows fourths? Is there a way we could prove that? Shade 1/4 of this square. Do you think each of the shapes are 1/4? How would you know that? Shade 1/2 of each square. Shade 1/3 of each square. Each whole square is blank thirds. If someone's with you, have a conversation about this square. Do each of these pieces show 1/3? Is there something we could do to tell? How could we prove it? If we look at both of these on this page, shade 1/2 of each square, shade 1/3 of each square, the number 3 is bigger than the number 2, but these pieces, when we have 3 of them, look smaller than when we have 2 of them. Can you think about that and why that is? What tells you the name of each part? I knew the square was divided into thirds because so let's talk about that. How do we know that this square is divided into thirds? How many pieces do you see? 1, 2, 3. Each whole square is 3/3. What about this square? Did you figure out how to tell if this piece matches the other two? Are they equal in size to this shape? What if you imagine dividing this shape right here in half and laying it over here, or laying them side by side? They be the same size? You could experiment with this at home. Draw a square on your paper, divide it into thirds this way and thirds the other way. See if they match. Our exit ticket today, look at all the squares divided above. Which parts are bigger, the halves or the thirds? Explain.